Good morning, everyone. My name is Sanit Kumar, and I have the pleasure of introducing to you Dr. Mozhgan Memari. She will be talking about a data quality framework for the University of Auckland Data Warehouse. She is the postdoctoral researcher and data scientist at Planning and Information Office at the University of Auckland. With over 9 years of experience in teaching and research, experience in information systems, including recommendation systems, technology adaptation, user experiences, data management, databases, data quality, and data analytics. She is also the co-founder of Snooperia, the data profiling and data management company. Please join me in welcoming Dr. Mozhgan Memari.
Thank you very much for the introduction. Good morning. Let me start with two figures from 2016. Firstly, I would like to think about the size of the big data market in 2016, but please think globally and consider worldwide. So how much you would estimate this market? Maybe you would say $100 million or $100 billion or even more. You might go to $1 trillion as well. Then I would like you to think about the cost of poor data quality. Just consider 2016 and only consider US. Just have these two numbers in your mind. And now I give you two numbers. These numbers are associating with these two figures. How many of you are thinking that the cost for poor data quality in US only in 2016 is $136 billion per year? No one? I think you're correct completely, because this cost is $3.1 trillion only for US. When we talk about the size of the big data market, we talk about a big market. And then when we talk about cost of poor data quality, it is getting much more expensive even. It is the reason that we need to talk about data quality. And another reason is we are gathering more data in the organizations. We want to have correct data-driven decision-making because we want to have crucial information in the right time for us. And also we want to transform data into value. We want to have useful information in the right time, and also we want this data to be trustworthy as well. Now we need to talk about and think about data quality, because we need these two figures to be together and work for us together. Otherwise, the decisions that we make based on the data, they couldn't be correct, because if we have crap data, it could be crap decision making based on that. Today, I very briefly talk about the data quality framework that we designed for University of Auckland Data Warehouse. And then I very briefly talk about the methodology that we use. And mainly, I would like to talk about the technical design of this, quality dimensions that we define, and the measures and metrics and tools and techniques. Just briefly, I go through the techniques, and then also I talk about how we're going to implement it in the data warehouse. A data quality framework is an assessment and measurement tool integrated into organizational process, providing a benchmark for the effective of any future data, data quality improvement, and it would be a template for information on data quality, both for internal and external users. Our objectives for designing such data quality framework was, firstly, we wanted to have useful data, and also we wanted data to be trustworthy. We wanted to measure the level of confidence in our data over the time, always. And also, we wanted to have a data governance policy for whole the organization. We came up with a conceptual model, including the governance for the data quality, some proposal over the roles and responsibilities, data custodians, data stewards, and technical roles that we need for data quality governance, and also a service delivery process, and mainly the technical model, including different metrics to calculate and measure data quality, and how to implement it. A data quality methodology is a set of strategies, guidelines, and techniques which describe the input information for a given application, and then define the data quality assessment and improvement process. There are some existing methodologies in the literature. We went through those, and then we decided, because we wanted to look at our applications and data stored in the data warehouse, we looked at data warehouse quality methodology. For this purpose, we need to look at objective assessments, which different techniques are applied to define the data quality values, and we use technical approaches to exactly measure the data quality values and quantify those values. But what we know, all of us, that the data quality is not the only responsibility, the technical people responsibility only. We need other people, we need stakeholders to come and talk with us about the problems that they have, about the priorities, about the applications, for example, that they want to fund it and improve the quality for that specific application, or even that specific object in their data. So because of that, we actually use data quality assessment methodology as well, and we combine it with data quality, data warehouse quality. Because in that methodology, they also differentiate between the objective assessment and subjective assessment of quality. By subjective assessment, I mean the perception and information needs and the data quality requirements of the stakeholders and business users. And we want to define and measure what they want as to look at in their data, and and to what extent they want to improve the data quality. So by data quality dimension, we mean how we're going to interpret data quality into practical and measurable concept. Because of this, we needed to come up with some measures, with some metrics to quantify data quality. In the data quality, in the University of Auckland governance policy, we had 4 objective metrics, which are completeness, validity, consistency, and accuracy. But apart from that, as I mentioned, we wanted to consider subjective assessment as well. We added interpretability, timeliness, and reasonableness, and also we added accessibility, which is another objective assessment or another objective metrics for calculating the data quality. So if you would like to have a look, for example, here, for usefulness, you need your data to be complex to be useful. You need your data to sound correct. When you see a report, you want to say, okay, I understand it. It is reasonable to me. It sounds reasonable to me. Or when I need it, I can access it. Or my business analyst, they can access the data in at any time that they need it. And as a matter of trustworthy, now we go further down, and we need to look at details of technical. And also we need domain experts to come and help us for defining the business rules, but indeed we need some integrity constraints to be checked. We need some accuracy tests and also validity. And also we have other dimensions here as well. So in the technical model, we have We have all those dimensions defined. For example, for completeness, indeed, we all know that we want to have necessary data ready when we need it. And we want valid data, which is reasonable and correct. We need to have consistent data, which refers to validation of semantic rules in our data. And as a matter of accuracy, we want to store and actually use the correct values in a specific object, as a matter of columns, dimension, fact, any table that we have. And when we talk about accessibility, we want our users to obtain and access data when they need. As a matter of interpretability, they need to have they need to have access to semantically meaningful data. And as a matter of reasonableness, as I mentioned before, they need to have they need to see a correct understanding of the data when they see a report. And timeliness, we need to look at the availability of the data and the time, actually, that they see the data available for any time they need it. So because of that, we define some metrics for each dimension. For each dimension, let's say for accuracy, we came up with three techniques to quantify that dimension. For example, for accuracy, we need to look at our reference data and see if our reference data is correct and accurate or not. And then accuracy of the target table after having the ETL process. For example, for consistency, we use different data profiling techniques to see the correctness of dependencies between the data, to see the uniqueness of the data when it is required to be unique. And as a matter of, for example, interpretability, I'm talking about one example of our subjective assessments. Let's say we want to see if this data is meaningful to our stakeholders and domain experts. So then we define a survey, asking them some questions about, okay, when you see that report, what do you think about this? Do you understand it, or does it make sense or not? So it is the combination of different techniques, from technical to even having some surveys, understanding them, what they say. So different techniques that we use to calculate any of those dimensions. And by this one, I mean the goals. So again, we have our domain expert and the stakeholders involved. They come to us and say, okay, the goal for me for this, for example, that object, or for that table, let's say, I want this to be 100% accurate. But it is all right if it comes to 95% reasonableness. These are just examples. We need to sit down with them and understand what they want from their data. And also because we always know that data is not clean. So we need to do some work. So they need to come up with some acceptable level or a lower band that they said, okay, if it is in that range, I say, okay, it is acceptable. And then I go and think about the application that I want to found it and do some repairs. And then the actual goals, these are the technical part of it, that we need to quantify all those things, data quality values, and come up with some actual values. For each specific dimension, we define such table with details of information about that dimension. For example, for completeness, we have 7 metrics, and then we explain, for each of them, we propose 1 or 2 techniques to quantify that. So the process. For the process, firstly, we need to discuss the business problem with our stakeholders. We cannot say, okay, we sit in the, in the IT department and define, okay, I want to do this. Firstly, we need to come up with the business problem, talking with our stakeholders, coming up with the goals, priorities, and also acceptable acceptance limits. And then now we sit down, data stewards, which could be our IT experts and also our domain experts. They sit together and they come up with the metrics that we need to calculate. We have validated this technical design over one application in our data warehouse. And in that pilot study, we have used some of those objects. I'm just giving you some examples. For example, for the business, one business problem, for example, calculating the level of confidence in only employee dimension in our data warehouse. So we discussed the total, for example, just looking at completeness as one dimension, data quality dimension. We say, okay, we want it to be 100% for sure. But let's say for data, for employee information, for some information, for example, middle name or some other informations, we are fine if we even get 95% completeness. For that purpose, now we need to define the metrics. We defined these 4 metrics because we had those, so we said, okay, for this purpose, based on those goals, we can actually use these metrics to calculate and quantify completeness for that specific dimension. So for coherence completeness, we need to count and compare the number of unique records in source and also in our target table. And then in the table and then in output would be the table level, which is our dim employee dimension. And then again, another metric which goes through column levels as well. And we look at the number of columns in our source table and also in our dimension, target dimension. And we say, okay, we want to compare the not null values populated from source table to the target table. And then it could be reported over column levels or table levels. And then we have another metric, for example, counting the required tuppers that are getting transformed from our source table to our dimension, which is the target table. And also the very simple completeness checking that we always do it, even in ETL process everywhere, is counting the number of not null values and then compare it with the source as well. So for example, for the first one, so we need these 2 tables, and then over the ETL process, we have our technique, and then we calculate it. We compare these 2 numbers and say, okay, the result of 100%. Again, adding some calculations for coherence completeness 2, we say, okay, we go over number of columns in dim employee, and we compare it with the number of not null values in the source columns, and then we compare this. So now we can actually report each column, or we can report all those. Another one is tuple-based completeness. Again, we compare the number of tuples that we need to be transferred, and then, again, all this happens in ETL process. Again, we get the number and we quantify it. I would like to give you some examples from consistency as well. So, for example, as you know, uniqueness is very important. So, for example, for checking the uniqueness of employee IDs for each person. So we check this uniqueness over our source table. And then also we check it in the target table. And it is getting a little bit different because now we have another design for our database. So we need to be careful that we always have unique employee ID using in our data for each employee. And again, we see that, okay, what's happening here? We need to go back. These are all example numbers. They are not coming from the data. So then we need to look at this, why we have this percentage and what's happening. And then the stakeholder design, okay, decide we need to go back and have a look what's happening and think about the maintenance process. Another one which is very important is dependency checking, again using data profiling techniques to come up with the deep dependency dependencies and relationships between columns or even tables. In this example, we only look at two columns. So indeed, for each position number, we would like to have one unique position description. So again, using some data profiling techniques to coming up with a number for the integrity in our data is very important. So what we are going to do with these data quality values measured. So we have our data warehouse, and now we want to have a data quality repository. We have our data quality fact, which stores the data quality values we measured. And then indeed we have a data quality measure dimension, which includes all those metrics that I explained till now. And also we have objects, all the objects that we have in mind that we want to calculate the data quality values for them. It could be whole database, it could be one table, it could be one column even. But again, we need to have those here as one dimension to read it in the fact. One thing which is very important is sometimes we have one object, let's say one table, getting used by two different stakeholders. For one stakeholder, for example, team employee is very important. They want 100% completeness, 100% integrity, 100% validity. But for another report, they might want an overall report on the data. So what happens then? So you need to define different interpretation and different goals for each specific object, for each specific stakeholders. So because of this, we came up with that dimension to have different acceptance level or even goals for each object, for each specific stakeholders. And then we have also some shadow facts and shadow dimensions. So let's say sometimes we want to go in details and we want to calculate the data quality of each tuple in each fact or in each dimension. So for that purpose, this design wouldn't work because we have this fact just showing one object. We don't go through all the tuples. Because of this, now we added this as a shadow fact or shadow table, shadow dimension, let's say to not interfere with the performance, daily performance of ETL, and also having the detailed information about the data quality on each specific table, a specific tuple, in the table. And finally, definitely when we have something in our data warehouse, we definitely want to get some reports from that. For example, for each application, for each object, we want to see what's happening as a matter of data quality. We can definitely, based on that quantified number and overall number that we calculate for each data quality, we can come up with one level of confidence for that object. We can go further down and give more a specific number, give a specific number for that, and then also we can show it through the time and show that how it improved or actually, let's say, not improved. And if now one person, one stakeholder want to see the details, and for example, it is 98%, I see 98% confidence in this data, but what's happening? So we can go through this and see, okay, as a matter of accuracy, this is the actual data is 100%, but what's the problem with reasonableness, for example? These are all numbers that I made. These are not correct based on the data. So, and again, if they want to see what's the problem here, they can go and see, report from the fact, data quality fact, and report, okay, what's happening here, where is the problem, and what I can do for maintenance the data quality. So I had limited time, so because of this, I very quickly went through the two main features for data quality that could save us a lot of money and also could help us to get better insight from our data in organization. And it is very important, and it is the time for thinking about this, because now we are gathering more data. So these two features, which are fitness and also trustworthiness of the data, is getting very, very important. And for each organization, it could be different. So for University of Auckland, we are running it to see, okay, if these dimensions are enough or not. Maybe we need to add more dimensions. Maybe we need to add more metrics, because during the time we see, okay, I don't have any technique or a specific technique that I can calculate the data quality or quantify the data quality of this object. So again, it is a process that needs update every time. And because of this, in the research also they are doing this, they are adding more new algorithms as a matter of data profiling, as a matter of data management, data quality techniques, and every time they are adding new techniques to that, because based on each application we need new things. And this, actually this framework is the first that combines the objective and subjective assessments of data quality for a data quality framework for a data warehouse. And I think we have a huge work in front of us, implementing it and testing it. And data quality is not easy, but actually we can do it because it is very important and it saves us a lot of money. Thank you very much indeed, and I'm happy to answer any questions you may have. Thank you.